Hello everyone, my name is Huda Dole and this is a presentation on simple linear regression. In this presentation we will cover the following key areas. We will carry out 3 regression tests, one of which will predict if one's debt can be predicted from their income. A second one will predict if a person's savings can be predicted from their income. And the last one will predict whether a person's stocks can be predicted from their savings. We will present the results for each of these tests in APA format and cover the main takeaways. We will discuss 3 important articles that have been covered in this course. In the end, the forum will open for any questions or comments. This regression test was for the purpose of establishing if an individual's debt could be predicted from their income. The analysis showed no significant regression, the results being beta equals minus 0.05, r squared equals 0.00, p-value equals 0.535. The null hypothesis was rejected, concluding that a person's debt cannot be predicted from their income. The second regression test was conducted to establish whether the savings of an individual could be predicted from the income of the person. A statistically significant regression emerged with a beta value of 0.91, r squared of 0.82, and p-value of 0.000. The test rejected the null hypothesis and concluded that the savings of an individual from this analysis can be predicted by the regression relationship. Savings equals 0.91 times the income of minus 203.47. In support of the prediction, the 95% confidence interval was 0.09 and 0.11, contains no zero. This regression test was conducted to establish whether the stocks of an individual could be predicted from the savings of the person. A statistically significant regression emerged with a beta value of 0.28, r squared of 0.07, and p-value of 0.000. The test rejected the null hypothesis and concluded that the stocks of an individual from this analysis can be predicted by the regression relationship. In order to predict stocks and savings, we use the following formula. Stocks equals 0.28 times savings plus 1006.73. In support of the prediction, the 95% confidence interval was 0.07 and 0.25, contains no zero. I learned from this project that regression analysis is another of the available data analysis approaches to establish a relationship between two study variables, unlike correlation and chi-square tests. I noted that regression analysis is a way to see if one of the variables, the dependent variable, can be predicted from the other variable, the independent variable. Using PSPP to carry out the analysis was easy and a comfortable task, making this software a great one to carry out regression analysis once the data has been correctly prepared and imported to the software. Lastly, I also learned that when a statistically significant emerges, the confidence interval range should not contain zero for the CI to support the significant regression that has emerged. In this article, the author covered important details related to correlation and the understanding of the significance of a correlational test. He opened the article by defining the correlation, which is the number that indicates the degree, strength, or weakness of correlation between two study variables, to help the reader comprehend the correlation method. Tromsø in 2006 walks through an example of how to compute the correlation in a step-by-step approach. In the calculation, he shows all the components that go into the correlation formula and how they relate with one another. After the calculation, he goes on to cover another important aspect of the correlation, understanding the significance of a correlation, as indicated by the correlation coefficient R. After a test for significance, Tromsø 2006 covers the correlation matrix, in which he provides the formula for one to easily determine the number of correlations given the number of variables under study. The author concludes the article by indicating three other correlations, namely the Spearman rank order row correlation, Kinder rank order tau correlation, and point biserial correlation, and it briefly explains when it's necessary to use each of these instead of the Pearson's correlation studied in this course. In this article, the author focused on helping the reader understand how to interpret p-values in research work correctly. The article opens by explaining the null hypothesis in hypothesis testing, which is described as the lack of difference between the study variables. The author of the article then progresses to explain p-values in abstract terms, noting that essentially p-values are used for measuring how well the null hypothesis fits the data. The author further indicates that, from a technical perspective, a p-value is a probability of obtaining a result as extreme as the sample, if the null hypothesis holds true. The article concludes by covering the error rate, in which the author is keen to explain that the p-value should not be understood as the probability of making a mistake, and notes that according to Silk et al., the probability of incorrectly rejecting a true null hypothesis is at least 23% and typically around 50%. When the p-value is 0.05 and the same error rate is at least 7% and typically around 15%, when the p-value is 0.01 in this regard, the author concludes that it is important for researchers to ensure that p-values are correctly interpreted, as the cost of wrongly interpreting the p-values can be critical and have a major impact on whether or not the study gets published. In this article, the author purposed to cover one of the various statistics used to indicate how well a linear model fits the data, the R-squared statistic. The article opens by explaining the goodness of fit for a linear model, where the author notes that for a fitted model to be said to be good, the differences between the observed values and those computed using the fitted model are minimal and unbiased. Minitab Blog Editor 2013. The author then explains the R-squared statistic as a statistic used to measure how close the researcher's data is fitted to the regression line when one uses linear regression as the data analysis method. The author explains that the R-squared value of 0 indicates that the fitted model does not explain any of the observed variations, while an R-squared value of 1 100% explains all the observed variations of the data around the mean. The author presents two graphs showing the differences between two regression models and further explains the point on how low and high R-squared values work in explaining variability in data analysis. The author then makes two important points on the limitations of the R-squared statistic, one being that the R-squared statistic does not whether the estimates of the coefficient and the predictions are biased, and second, that this statistic does not necessarily show if a fitted regression model is adequate. The author closes the article by noting that researchers should always not perceive low R-squared values as bad and high R-squared values as good in explaining the variability in data analysis, as this is not always the case. Concluding, these articles were extremely useful in helping me understand the concepts of p-values, correlation, and the R-squared statistic. Each of the topics on these articles was comprehensively covered, and this made it easy for me to understand the points that the authors were making. Also, as seen in the articles, each of them covered a specific different topic from that covered in the other articles, which was good for me as using one article at a time to understand the specific area of focus in the article, made it easy for me to comprehend the content. In cases where it was necessary to support an argument with examples, the authors did so, like the use of a manually calculated example in the Tromsø's 2006 article on correlation and use of graphs to illustrate the meaning of R-squared as a statistic for explaining how well a linear regression model fits the data. Also, each of the authors of the articles explain the content in an easy-to-understand approach, even for someone not knowledgeable in advanced statistics, and some of the topics the articles covered. Overall, the content from the articles substantiated the content I learned from the course readings, especially the course text and the lecture videos, and made it comfortable for me to understand each of the topics covered more. Thank you all for watching. Please let me know if you have any questions or comments.